Every sterile processing tech knows you need to check the sterilizer printout at the end of every cycle. But do you actually know how to read it? Those little numbers that represent time, pressure, and temperature, they all tell you a very critical story of whether or not your instruments are truly sterile. And today, I'm going to show you exactly how to break down a sterilizer printout, what those numbers really mean, and how to catch the red flags that could literally mean the difference between life and death. Let's get into it. Welcome back, everyone. I'm Brandon, the Sterile Guy, and on this channel, I cut through the confusion and make sterile processing simple so you can pass your exams, grow your skills, and protect patients. I just wanted to give a little shout out. You might see me wearing some pretty cool shirts on this channel, and I get all these shirts from 80stees.com. And I put a link in the description for every shirt that I wear. But today I'm wearing the Simon Says shirt. So just pretend today that I'm Simon as I tell you how to properly read a sterilizer printout. Before we jump in, don't forget to like the video and hit subscribe so you never miss a future video. In this video, I've chosen to use a sterilizer receipt that someone shared a while back on a sterile processing Facebook group. It's an excellent resource, and thank you to whomever shared this piece of art. Now here's a typical steam sterilizer end of cycle printout. It's basically a receipt that records the entire cycle from start to finish. Now there's a few colors of highlight that I want to point out here. The orange highlight, which represents the pressure readings, the pink highlight, which represents the temperature readings, and the yellow highlight, which represents the exposure time. These are three very important things that you need to focus on and learn for sterilizer printouts. This person put a lot of other great information on this receipt, so don't just negate those. But today I'm just focusing on those main three. We can't see inside a sterilizer to truly know what's going on in there. So together, between indicators, biologicals, and the sterilizer printout, these will tell us the story of the cycle. Let's break it down, starting with pressure. Pressure isn't just a number. It's how the machine achieves the proper steam penetration that's needed to kill all the microorganisms. For steam to reach microorganisms at 270 degrees Fahrenheit or 132 degrees Celsius, you need about 27 to 30 pounds per square inch. No pressure, no sterilization. Historically, pressure standards were figured out through microbiology studies, going back over 100 years, proving exactly what it takes to kill resistant spores. Now moving into the pink highlight, temperature. Sterilization only works if the chamber reaches and holds the correct temperature. Temperature too low, not sterile. Temperature too high, it could damage your instruments. The common ranges are 250 degrees Fahrenheit or 121 degrees Celsius for gravity cycles, and between 270 and 275 degrees Fahrenheit, which is 132 to 135 degrees Celsius for prevac and SFPP cycles, which is your steam flush pressure pulse. And lastly, the yellow highlight, which is our exposure time. This is the duration the chamber stayed at sterilization temperature and pressure. And here's the key. The sterilization time doesn't start when you press start on the machine. It starts once the machine actually reaches the target pressure and temperature. On the printout, you'll see that moment clearly. It's usually designated by the letter S. And that's the number you look for when confirming if exposure time requirements were met. Let's talk about the sterilization plateau on the printout, which is another term you may hear concerning the exposure phase. Plateau, meaning the temp and pressure reach a minimum and then plateau for that duration. They don't go up or down. Let's see on the receipt exactly what occurred to reach the exposure phase. If you look at the line just before the yellow highlight, you'll see it was at 5:40 a.m. and 24 seconds. The chamber was at 214.5 degrees Fahrenheit and a pressure of 1.4 psi. Now, between 5:40 and 24 a.m. and 5:43 and 14 a.m., the chamber increased both temperature and pressure until at 5:43:14 seconds a.m., they both hit the exposure spot, starting the clock, which is why the line starts with both numbers in range. Then on this particular sterilizer, the receipt captures the current pressure and temperature every exact minute thereafter until it reaches the full exposure time, which on this machine was set to 4 minutes. Starts at 43, so 44, 45, 46, 47, 4 minutes. Exactly when the sterilizer reaches 5:47:14 a.m. with both temperature and pressure having held within exposure thresholds for the full time frame, the exhaust phase kicks in to complete the exposure phase, which you'll see on that very first line starting with an E for exposure. So for example, a gravity cycle at 250 degrees Fahrenheit needs a 30-minute exposure. Pre-vacuum and SFPP cycles at 270 degrees Fahrenheit are anywhere from 3 to 4 minutes usually. The machine records this automatically, but you need to know how to identify it on the printout because if that plateau isn't long enough, the load cannot be released. I pulled a great graphic from Steris which actually shows you the difference between a gravity, pre-vac, and pressure pulse cycle. You'll notice some key differences between cycle types. First, let's orient using the gravity cycle. You can see there is a 0 point for reference for no pressure or vacuum, just standard atmospheric pressure, which is the air you're breathing right now. Now, a gravity cycle stays in positive pressure the entire cycle from amp up to exposure until it finally exhausts to dry the instruments, and that's when it pulls a vacuum. Now let's add the pre-vacuum cycle. You'll see multiple pressure and vacuum pulses at the beginning. Looks like little stair steps, and then a sharp rise to temperature and pressure. You'll know it's pre-vac because it crosses the atmospheric pressure line and has both pressure and vacuum. Lastly, bringing in all three to compare, here's the SFPP cycle, the steam flush pressure pulse. It's similar to pre-vac, but the pulses never utilize vacuum to condition the chamber. Instead of pulling deep vacuums, it flushes with steam while cycling pressure up and down, always above atmospheric pressure. The printout looks more like a rolling waves before hitting the sterilization phase. It then only uses vacuum to exhaust and dry instruments, which is similar to the gravity cycle. Knowing these differences helps you confirm you're looking at the right cycle for the right load, but also makes it so you can easily distinguish what type of cycle you're actually looking at. So here's a $1 million question. What could go wrong? A sterilizer may fail or abort, but does not always give you a good idea of what is happening and potentially why. So here are some variances to look out for. Temperature too low during exposure. This is one you'll probably notice right away since it is the most important phase. It could mean a faulty steam supply or maybe even a sensor issue. Pressure dropping in the middle of exposure. Possible leak or premature venting. This could be issues with the door seals, this could be valves not completely closing, or even being stuck open. Exposure time too short. Maybe the cycle was aborted early, or the wrong cycle was selected to begin with. I've run across this before where tech was freaking out about a cycle not reaching proper time, and after some investigation, we found that someone had improperly programmed a cycle. Very important to inspect the cycle parameters before you choose that cycle. Unusual spikes or dips. This could point to mechanical problems with the sterilizer, or it could also be faulty sensors. With most of these issues, it is imperative that you get your sterilizer-trained biomed tech or a contracted sterilizer technician to tend to them quickly. In any of these cases, the load cannot be released until the issue is resolved and the cycle is rerun successfully. Remember, the printout is your legal record. If a patient safety question ever comes up, that slip of paper is what gets reviewed. This is why these receipts should be kept in the physical records or be scanned into your digital record keeping systems. So that's the basics of reading a sterilizer printout. Pressure, time, and temperature all work together to confirm sterilization. And now you know exactly how to find the exposure phase, how to spot differences between cycle types, and what red flags to watch out for. If this video helped you, hit like so other sterile techs can find it. And if you want more deep dives into sterile processing essentials, throw those requests in the comments down below. Thanks for watching. I'm Brandon, the Sterile Guy. I love you guys, and I'll catch you in the next one.